Okay, let's take a look at some restrictions on logarithms. So if I have my general form log base b of a equals c, the thing I'm logging, a, needs to be greater than 0, and my base also needs to be greater than 0, and my base cannot equal 1. So those are going to be the restrictions. Just like denominator cannot equal 0 and we can't square root negatives, this is going to be another restriction that we'll need to remember. So let's take a look at a few examples. Log of 0. We cannot do log of 0 because 0 is not greater than 0. Let's take a look at log base x of a number. So I know that this base x needs to be greater than 0. Also, x can't equal 1. And those will be the restrictions. Let's take a look at log base 0 of a number. Well, again, we cannot do that because the base needs to be greater than 0 and can't be 1. Let's take a look at log base -2 of 5. Well, we can't do that because the base needs to be greater than 0. Let's take a look at log base 1 of 7. Well, we can't do that because x cannot equal 1. So let's take a look at an equation. Log base 2 x equals 2. So I know that the thing I'm logging is equal to the base to the other side. 2. And 2 squared is equal to 4. Now the restrictions are x. Well, x is the thing I'm logging, and x needs to be greater than 0. Now I'll look at my answer, x equals 4, and that is greater than 0, check mark. Let's take a look at another example. Log base 2 of x minus 5 equals 2. Well, in the notes you can see solving the equation, all I'm going to do is the restriction. The log needs to be greater than 0. If I add 5 to both sides, x is greater than 5. So my answer must be greater than 5. Let's see another interesting example. Log base 2 of 3 minus x equals to 3. So again, in the notes, you can see the solution. I'm just going to work on the restrictions. The thing that we are logging needs to be greater than 0. Now I'm going to subtract 3 from both sides. Now I'm going to divide by -1. And I remember, if I divide both sides by -1, I need to change the direction of the sign. So x needs to be less than 3. Okay, let's see some more restrictions. Log base 3 x squared equals 2. So I'm actually going to solve this equation. So the thing I'm logging is equal to the base to the other side. So x squared is equal to 9. Now I'm going to square root both sides, and remember that x is equal to plus or minus 3. So I'm going to state those answers side by side. X equals 3 and x equals negative 3. But I have to work on my restrictions. The thing I'm logging needs to be greater than 0. So if necessary, please review grade 11 inequalities, but I'm going to prefer to graph x squared with a table of values. So 0 squared is 0, 1 squared is 1, 2 squared is 4, and all my identical points. So where is this thing greater than 0? Well, this thing is greater than 0 here and here. Now, where is that true? Well, x must be greater than 0 and x must be less than 0. Now, these are two redundant, unnecessary extra information. If x needs to be greater than 0 and x needs to be less than 0, all I know is that x cannot equal 0, and I can give one simple restriction. Now, both of my answers don't fit into that restriction, so check mark. Let's see another similar example. 2 log 3 of x squared equals, of x equals 2. Now, this question looks extremely similar to the last one. Soon, on the next page, we're going to learn that this exponent can be brought up. So, almost identical questions. But let's not do that. And let's answer the question. So, I'm going to divide both sides by 2. So, log base 3x equals 1. Now I'll change to exponential form. So x equals the base to the other side. Therefore, x is equal to 3. Notice we don't get plus or minus 3 like in the last question. Now the restriction on this is simply x needs to be greater than 0, which coincides with our answer. So interesting, different reasons why we have to do restrictions and how much stuff we have to go back and learn about. A little bit about inequalities, dividing both sides by a negative, possibly using graphs. A little bit more on restrictions. Log base 36 of 5x minus x squared is equal to 1/2. So if I change to exponential form, I know 5x minus x squared is equal to 36 to the 1/2, changing from log form to exponential form. And if I work on the right-hand side, 36 to the 1/2, well, what's that? Well, I know from before that we have our rule x to the m over n is equal to the nth root of x to the m. So 36 to the 1/2 is equal to the square root of 36 to the 1, which is just equal to 6. So 36 to the 1/2 is just equal to 6 because the square root is just 6. Now I'm going to get it all onto the right-hand side. So 0 equals. If I add x squared to both sides, I have x squared. If I subtract 5x from both sides, I have minus 5x. And 6 stays on that side. So now I'm going to factor it. 0 equals, two numbers that multiply to get 6 and add to get negative 5 are going to be negative 2 and negative 3. Then I can solve the equation, x equals 2 and x equals 3. Now I have to work on my restrictions. So underneath the thing that we're logging, 5x minus x squared needs to be greater than 0. Now, I don't like the equation in that form, but I will leave it and factor out an x. So if I set my factors equal to 0, I get x equals 0 and 5 minus x equals 0. Therefore, x equals 5. Now this is just to find the arbitrary x-intercepts. So if I draw a graph, I have x-intercepts at 0 and 5. Now I know that my parabola has a negative x squared, which means that I know the parabola is opening downwards. Now where is this thing greater than 0? Well, that's where the y values are greater than 0, and that's here. And the domain restrictions is 0 less than x less than 5. So I know that my answers need to be between 0 and 5. X equals 2, correct. X equals 3, correct. Both between 0 and 5. Please feel free to do the rest of the notes or read through them and see the different restrictions and inequalities and understand why we restrict some of the answers if they are outside of the domain. Okay, let's see another log equation. So log of x minus 3 of 16 is equal to 2. So remember, the base to the other side, the thing you're logging equals the base to the other side. Now remember, squared means times by itself. So 16 is equal to x squared minus 3x is minus 6x, and minus 3 times minus 3 is positive 9. Now if I subtract 16 from both sides, 9 minus 16 is negative 7, and if I factor it, two numbers that multiply to get negative 7 and add to get negative 6 are 7 and 1, negative 7 and positive 1. Therefore, x equals 7 and x equals negative 1. So what are my restrictions? Well, this time we have a base of x minus 3. So we know that x minus 3 needs to be greater than 0, and we know that x minus 3 cannot equal 1. So if I solve the first equation, x needs to be greater than 3. And if I solve the second equation, x can't equal 4. So I want to think about my restrictions like on a number line. If x needs to be greater than 3, that means that I need numbers over here. Now x also cannot equal 4. So I can be greater than 3, but can't equal 4, which means we keep both of the restrictions. Lots of the times we reject one of the restrictions because the other one is more restrictive. So x is equal to 7 and x is equal to negative 1 are two answers. Well, 7 is within that domain, but negative 1 is not. Therefore, we reject negative 1, and the answers of this question are x is equal to 7, and x needs to be greater than 3, and can't equal 4. A little bit more on restrictions. Let's say x needs to be greater than 3, and x needs to be greater than 5. Well, again, let's think about it on a number line. So if I know that x needs to be greater than 3 and x needs to be greater than 5, well, I know I'm going to be this way. So lots of the times it's easier just to pick an arbitrary value. Well, let's pick 4. Well, is that greater than 3? Yes. But is that greater than 5? No. We need to choose the more restrictive domain. We are going to keep x needs to be greater than 3 and x needs to be greater than 5 is rejected. It's unnecessary information. We already know x needs to be greater than 3. We don't need to redundantly say that x also needs to be greater than 5.